game devs. In this video, we're going to get deeper into stealth and talk about it from a high-level overview. In Intro to Game Design, I realized that a lot of you are going into a side-scrolling game and have gotten some stealth mechanics, so I thought I'd cover this a little bit so that you can get a sense of what it is that you're probably going to need to do. And, you know, a lot of this is up to you to design and to implement, and the style of what your game is going to feel like is going to be based off of the way you implement these things. Just like Mario feels different to jump than Banjo-Kazooie. So stealth at its core is a rhythm puzzle game. That's the way I think about it anyway. Often AI are on timed paths, and players are challenged to thread the needle, going through stopping and starting like a giant obstacle course. Typically, stealth games integrate AI such as guards, humanoids, animals, or security cameras, sound, like footsteps on the ground, or things that the player touches. And those are generated when the player interacts with the environment. And the AI can also communicate to each other with sound, alerting other guards, saying that they might have found something, those kind of things. Additionally, line of sight is also critically important in a stealth game. Players, can they be seen? Are they in darkness? Are they behind a barrier? But the most critical thing in stealth is feedback. Specifically, the way the AI provides feedback and the way you provide feedback to the player. For instance, how much shadow are they in? So let's take a look at AI in Thief and break this down a little bit and look at the state machine and how it is that they designed their AI.
Hey, I'm going to the bear pits tomorrow. You want to come with? Couldn't pay me enough. What? You soft belly. The bears have got these new muzzles with underslung cheek spikes. Last time I was there was a real eye gouging. Nah. It makes me sick. When I was a kid. Huh. Surprised you're even in this job.
Ooh, the blood it turned my poor tummy.
Shut up, you taffer. You want blood? You should have been there years ago. Tell you, the bears then, they were something to see. Those bears, they didn't need no cheek spikes and razor collars and paw hooks and all that knifery you
Come into the
scraps to
open and
them.
try that again. No paw hooks. What'd they do? Just keep alert. Bump into each other. Something.
When I find you, you'll regret it. Hiding won't.
And the way that we do that is with AI states. Thief is a really interesting game. It's a stealth game. There's the player, and the player is tasked with collecting money, usually stealing something specific. So you might have to steal like a crown or whatever. And the way you do the way you go about doing this is that you maneuver through the environment and you avoid guards who are patrolling around. There's also zombies in there as well, but we're not going to talk about the zombies right now. We'll talk about them in a minute. So the way this works is that we have ourselves a guard, and the guard has a state machine, and this, what it does is says, I should be doing this. And inside of this, we put rule sets. So whatever it is that the state is, and we'll go over and break down the thief AI specifically. Whatever that state is, do those things, obey those rules, and then change out your state to another state based off of a series of inputs or player inputs or different conditions that you're looking out for. In the case of thief, there are 4 states. And the first one is a pretty obvious one, which is not alert. So in this state, we get regular patrolling, witty banter, that kind of thing. And you walk, and then the guard AI usually have an area of detection. And then let's just say that that's a radius of 10 meters. So, it's not exact, but let's say that a guard, if it was light, would be able to see you within 10 meters. And so the player in this case is performing stealth. Stealth being, and we'll just put this up here, is hiding in shadows and detecting and making noise. So when you make noise or when you hide in shadows, this increases or decreases the amount of area of detection just in any state. So we've got this not alert state. So let's say you did make a noise, or maybe the AI saw you at the edge of the 10-meter range. So we might then get to alert as a stage. Woo. So we might have alert. So in alert, we might obey a different set of rules. This rule might be set alert position. We might say, hey, now that you have seen something, where did you see it? Where are you? And in which direction are you alerted to? So once this is happening, the AI is going to go through a series of different steps. It's going to walk towards the disturbance, and it's going to increase its area of detection, or detection threshold, or something like that. And we'll just say like 10%. Okay, so you increase the detection threshold by maybe 10%. So that means that you're extra alert, and then you might have been found. Oops, we might have been in another state. Once you've been found, engage. So this is attack the player. Call for help. And run away if health is below 20%, or something like that. So once the AI sees the player and is engaged, so maybe this is within 5-meter threshold, so you're alerted at 10 meters, but if you're within 5 meters, the AI immediately engages, but because they close the gap, they engage a little bit later. They have a different set of AI. They behave differently. The other thing we've got is, and then we've got this fourth state, which is alert, engaged. So this is a longer cooldown. The AI are more more thorough in search on high alert. So in this a scenario where we have the AI engaging the player, and then the player was able to escape and hide, but the AI are still alert and engaged, that means that they might be looking more thoroughly. So when we're programming AI, we often create search patterns for geometry. That's kind of something very straightforward for a lot of AI is trying to look through the area. So how does the AI do that? Now, the player is actually known where, the computer knows where the player is, because the player is a digital representation in the computer. So we might have a hardness difficulty, which tweaks percentages. It might tweak cooldowns, etc. So we might be able to then continue to change the kind of the way that AI are handled based off the difficulty as well. But this is the basic state machine that most stealth games go through. Not alert, engage, alert, and engaged, where it was recently attacked or whatever. So now this is actually one of the questions that I asked Tim Stelmach when I interviewed for my first job, because it drove me nuts, and we had a really great discussion about it afterwards, and he explained something to me. So in this game Thief, there was these AI, and the AI were zombies, and the zombies are AI that kind of were laying in a crypt, and then they suddenly spring up to life and they go, Well, I always had trouble with that level, and I thought, well, they're supernatural beings, maybe they can see in the dark or something like that. And it turns out that they were actually using the exact same set of AI that the guards were using, but the messaging was different. So one thing, this is just kind of a side note as we're creating AI and we're creating states. So one of the things that we need to do is communicate our state to the player. Now, you're also going to be communicating this state to all the other AI, and there's coordinations and stuff, but one of the most important things to do when you're thinking about this is, how do you telegraph what state the AI was in or is in order to tell the player what they need, how they need to react, or how they need to behave? Because players, they pick up on this kind of stuff too. I asked him, like, what was up with the zombie AI, and he explained to me, and we kind of broke it down, which was the AI were running off the same human AI, but the zombies, they had a couple inputs. When they were in their not alert presence, they would go, and then in their alert presence, they would go, and then in their engaged presence, they would go, So it wasn't enough feedback for me, at least as a player, when I was starting out, to kind of figure that out. Whereas the human AI had much clearer state telegraphing, and they used to just be, they would have funny stories they would tell in their not alert, and then in the alert phase, they would be calling out, like, oh, I'm looking for you, Tapper, or, huh, what? That kind of stuff. So it was much easier to tell, and they also had swords or weapons, so they would pull them out when they were alert and engaged. So that was all really much better feedback and communication. So when we're communicating to the player. This is just kind of, side note kind of information that's really important. Now, stealth in side-scrolling runs into a few roadblocks that really diminishes a good stealth game. So many developers have to work with characters, and clients generally tend to have characters because it's a movie or just a game that you want to look at what the character looks like. So having these beautiful main characters can actually be a challenge, especially when you're making a good stealth game, at least when it's side-scroller, because they want them to be showcased, which means they want them to be as zoomed in as possible. So you want to have the most character that you possibly can. The one other thing that Corgi does really well is, as you know, or if you haven't gotten into it yet, there will be a video later about camera work. We can actually utilize the Corgi camera and pan things over, do a lot of the heavy lifting along with Cinema Machine and Timeline. You may not get into this very much, but if you're working on a game like Prince of Persia, Sands of Time, or any other kind of platformer, there's often times where you're going to want to use the camera to kind of showcase what's going on in front of you as you enter a room. That can be really used to your advantage, and you'll be able to quickly create different spots to set the camera to go to and then come back to the player. One of the awesome things about Corgi is that a lot of things hook up straight to the regular Unity system, so you can use the same skill set that you normally use when you're using Timeline or Cinema Machine. However, line of sight in side-scrollers are severely limited. You can't look behind in the background. That's not a very useful indication of what enemies are around you because you don't interact with the background. So you're really limited to whatever the distance is between the main character and the edge of the screen. So screen real estate, generally miserable. Games like Mark of the Ninja by Klee solve this by using strong camera work. As players enter and exit rooms, there are new areas. There is usually camera work moving around, and there's a lot of framing. Mark of the Ninja specifically provides extreme levels of feedback on just about everything. And there's a lot of also foreshadowing camera work, so they might zoom in or go someplace to display something as you enter. So camera work can be very, very important in the side-scrolling version of stealth games. So it's always going to be a balance between the size and position of the player on the screen and the amount of screen real estate that you're going to have. The second consideration is passing, going past a character while you're in the same space. And in 3D games, this is really easy to pass an enemy. You just go around them. But in side-scrollers, we are mostly using verticality. So you have to jump and go over if you're going to go around. However, in 3D games, we actually have all 3D space. So you can probably go up and around as well for those characters, for those as well. So you're usually forced to move vertically. But the way that we solved this in Madagascar Operation Penguin was adding a smile and wave, boys, move to the game. This is something that's really similar to other games. You might have a crate or a doorway in the background, and you press up or X to hide, and allowing the enemy and AI to pass in front without being able to interact with the player. For instance, when I was back in Kryptonite, my colleagues Darby McDevitt, he was working on Assassin's Creed 2 Discovery at the time. And they used hay carts and also assassination to go past AI. So if you ever played most of the Assassin's Creed games, there's hay cart, and Darby used that to put a hiding space so that we can go into the background and kind of get past AI problematic things. And that becomes really, really helpful, allows you to get back and forth, and is probably one of the more critical mechanics that just should be there if it's a side-scrolling stealth game. So how do we do these things in Corgi? Well, let's take a look at the default controller. Corgi has a character lookup.cs script, which lets the player look up in a specialized animation and camera movement. So all we have to do really is modify that script, and instead of a camera shift, we're going to alter the script's lookup to be hideup.cs. Make sure that you remember to rename the class name as well. I think it's like line 4 right in the declaration to match the file name. And in that code, you'll see on line 52 and line 101 that we've got lookup function and exit lookup. We'd use these similar to the way we'd want to use the function of hide. And instead, we're just going to hide. And if you're being a good programmer, you should probably be renaming these things a little bit and understanding them, but at the very least, we should be able to reuse these. They're private functions; they should be fine. You're also going to need to do a little special casework. You're going to need to disable the enemy ability to see the player and re-enable it when you hide in an object. So if you were using the Corgi engine, you're probably going to want to use the AI brain system in order to get stealth interactions going really well. Now, you don't have to do this. When on Madagascar, for instance, the characters were just AI that were the most basic AI that just bounced back and forth, and they had just a collision box where if the collision box touched the player, then you were seen, and then the game ended. So there wasn't any extra behavior beyond that. And that's the most basic way you could do stealth, where you are seen and then you reset the level. So no need to do all the AI stuff. But if you're going to get a little more complicated, the AI decision scripts are really helpful. And we can see similar behavior in those scripts. So instead of detecting when the player is facing away from the enemy, which is one of those scripts that's just like the ghost boo, you could actually take that and write a decision to ignore the player in the hide state. So don't attack if player is in hide state. Don't forget to put the custom hiding animation in your player's character controller as well. That'll also make it really interesting. Usually what we were doing in 2D games, and 3D games would look different, but in 2D games we would usually just color the character to look like they're in shadow. So we just change out the palette or palettes, shift it a little bit so it's in a darker scheme. What else in Corgi could we use? Let's keep going with that high level overview and tackle some of those other stealth features. We could do light-based vision. That can be implemented a few ways and also hooks into our AI decision system. The one that I was looking at was AI decision distance to target.cs, which is figuring out how far away you are from the target. So if we're going to use that, first we need to lay out our light sources. I've found that in stealth games, it's easier to control and tweak stealth systems by separating the actual lights in the scene and instead using polygonal zones with values that explain how lit or in shadow a player is. And they wouldn't overlap, and you would cover the map with these polygonal areas. So these light zone objects interact with our evaluate distance function on line 43. And instead of using distance, I think I would hijack this code and tell the enemy it's farther away than it actually is based on the light zone value. So basically, I'm going to use those values to modify how far away an enemy thinks that a player is. So if it's in a dark shadow, we divide the distance that we're detecting. If they're in full light, maybe there's no modification, that kind of thing. Now, there are much more elegant solutions, but we're doing quick and dirty with our first projects, and this method also allows you as a developer to modify these zones and values and create spotlights and other moving objects as well that can, although limited to one type of site, we could also extend to different characters. So we might extend this in even farther, and we might add a check to see what type of enemy am I and apply this % value modification to the distance variable as well. We could get really deep into it, but we could probably get away with just one. We'll probably only have about one enemy in this demo. So what about sounds? Well, we can also generate large invisible triggers when we generate sound cues. And leaning on the other AI decision code, we can return true in a sound trigger event and incorporate that as a go towards sound event. So if AI have a function where they are touched by any sort of sound trigger, then they will want to go towards that sound or do whatever their AI is that they need to do. Maybe they run away. Maybe they're a guard that tells other guards and then yells in the next room, and maybe there's some complex AI that allows you to then drag enemies from one room to another. That would be really fun. Those are the kind of things that are all part of your system. Maybe there's a return position or maybe there's not. Really, it's up to you how complex you want to get with your AI, but enemies reacting determine the difficulty and feel. This is just one way to implement things. There's arguments between using a zone system like I described versus using real gradients calculated by light distance and intensity. So there's plenty of discussion online about how it is that you should do things, and this is just one way it might get your brain going. So what's your favorite stealth game? What do you like about them? What is it that makes them unique and different from other stealth games? Let me know in the comments down below. Other than that, I will see you in class.